Hello developers, let's start developing. Today we're gonna take on the ninth task of the 2023 Advent of Code. Well, the story is that we have some numbers and each of these numbers represents some kind of a measurement that goes up. And our goal is basically to predict the next line based on this one. How do we do that? Well, it explains in details the technique, and the technique is actually something that is called numerical differentiation. So, whatever we do, we're taking the differences between two adjacent elements and we keep doing that until we get to zero. And if the input is something that is generated using a polynomial function, it will get to zero. That's a thing that's defined in math, basically. So we need to do that. And here we have a linear progression, basically 6, 9, 8, 6, 3, 6, 9, 12, 15. So the next one is going to be 18. And the difference is constant because if we take, that's a linear function. If we take the derivative of a linear function, we get a line. And if we get the derivative of a line, we get the zero line. So if we do the difference twice, we're getting all zeros. And we have another example that goes 1, 3, 6, 10, 15, 21. This is a square function actually. So we need to get the derivative once to get a line, and then we get the derivative once more to get a horizontal line from that, a constant line. And when we derive the constant line, we get the zero line. And then, of course, we can revert that process to get the next value. So, seems like a straightforward thing. And here we have something that is not linear. Most of these won't be linear, I think. They will be, yeah, this one is, I guess, linear. They will be square or cubic or whatever we want to do. I think there was an example of a cubic one when we need to go one even more. So this is constant, linear, square. Yeah, this is going to be some cubic thing, but we don't care. That just means that we need to do maybe a bit more calculations. However, let's start with getting the input, and in this case I think that's gonna be a relatively straightforward thing. So our input is gonna be just a set of numbers. So we have our lines dot split on a space. And from what I've seen, we don't have a double space. Not here. Do we have a double space somewhere around here? No. We have 4,000 spaces, but no double space. Which means that if we split on a space and then map this, oh, lines dot map, and then for each line, we split the line on a space and then we map each thing, item, with a parseInt with base 10, then we get the input actually, measurements. Those one, then we return the measurements. So instead of having a string array input, our input is basically an array of numbers. So that is our input, and that is what we're gonna do. So, and we need to actually provide the sum of all the next things. So this means that we're gonna need to have a function that will just add them up. So let's write that in kind of sort of pseudocode. So for the input, we're going to need to map the input for each measurements. Let's call these measurements. So for each measurement, we need to do get next value for that measurement. Bug. And we actually need to sum these up. As I said, we have a sum helper. So we're gonna need to have a get next value function. This is not it, so I will just replace this with a -1. And this is the result. So let's try to run this to see if we have the correct behavior. Let's log the measurement, and now we can say npm start 9. We should be able to get a wrong result, but to inspect that our input is correct, and the result is 3. Oh, we're still returning measurement length. We're not returning the result. The result should be -3 this time, because we're saying the next one is always -1. Yeah, now the result is -3. The data seems correct. So, okay. So now we're going to need to do the actual code. The actual code will be here in the get next value function. So for this, we will need a way to get the differences between items. So I would like that to look like this. So measurement.diffs. Because this is a function that actually makes sense to use on an array to get all the piecewise differences. And since this is a array function, I'm going to say differences. So we shouldn't be stingy on letters. But this doesn't exist, just like sum doesn't exist. However, I have a special file where I'm defining these things. So I will define differences, which will take a selector as well. Because in order to calculate differences, we kind of need an array of that. So the differences, yeah, it will always be a number array, because if it's not a number, differences don't matter. And because we might have a different type of item, that means that we might want to convert this thing into a number. And just on a side note to explain that the thing that I'm doing right now by redefining the array interface, this is a thing that is actually called prototype pollution, and it's usually a bad thing, because if I add a method to the array object, that method will be available everywhere where this is included. And that might be a good thing, but there's just no stopping that somebody else will be able to do this as well, which means we might have two different methods called differences with different behaviors that actually work in one piece of the code. One thing is working, and another piece of the code that something else is working. Since I'm the only one that's actually generating and using this code, I'm fine with prototype pollution. But in general, and especially if you're using libraries, those libraries should not do prototype pollution, because if you're working on a library, you just have no idea how the user will be able to use that. So in general, avoid prototype pollution as the plague, unless you are the actual end user and it's nicely documented. And the next thing is that we actually need to pollute that prototype. So we're gonna say that we need to implement the array differences. I have no idea if this is the correct implementation. Basically, based on everything I've written, Copilot generated a function that I'm seeing for the first time, and the awesome thing is that it's actually quite in line with whatever I've done. So the awesome thing is that it's using my specific style to generate this. Because, yeah, I always want to use this. And it detected that, oh yeah, all of the other things are using this line, so use it as well. So this, I'm capturing this into an array variable, and I have a default implementation because I said the selector is optional, and if somebody doesn't give you a selector, then we're using the default selector, which is a straight mapping. Otherwise, we are generating a new array, which is the result for the index starting at 1. We're taking the two items, so there we're taking the two first items. We're calculating their differences. This is not optimal. So I will change this. Values is gonna be array map using the selector. So we have the values now, because this will generate for the second element. The second element gets compared with the first one and with the third one. So that means that we're going to calculate its selector twice. In general, if we can calculate it once, it's enough. So we're just going to do that once. And then I will just say values, values, values here. And then we're just pushing the element minus previous, and we're returning the result. Let's see if we get something differences. Let's console log the differences and console log the measurement as well, and return, yeah, -1. Let's see if this is operational. Yeah, these are the differences, these are the differences, these are the differences. So far, so good. So the first level of differences is done, which means that we can continue onward and forward. So of course we can divs dot differences. Do it once more and do it once more. Oh, actually, why not? And this is the first few levels of differences. We will get them. So we will get zeros and zeros and ones and twos, and you get the gist. So this means that we're gonna need to do one set of differences most likely, because I don't think that even in the input had the situation when we had all zeros. In an input we might have some zeros, but we never have a zero followed. So the sets of differences will be an empty set. That's an array of numbers, and we can say we can actually use a do while loop. Now there is a reason I don't want them, but actually I will say that let diffs equal measurement dot differences. We're gonna get one set of differences and we're gonna push them into the diff sets. Actually, why not just push them directly? Then we don't even need this because this is gonna be a number array by default. So the first set of differences are inside. No, not really. So the first set of differences is the measurement itself. And we can say now, while the last diff set, we're going to take the last diff. I will just call that a diff, and we can see if every item of that is equal to 0. And then we need to stop. So we actually need to invert it so we can ask whether some item is different than 0. So while the some item is different than 0, we're just running this. We're gonna get the last set, compute the differences for it, and push it into the next set, and then we're done. So we can just console log the diff sets and return -1 once more. Let's see how that goes. So we should be able to go all the way until we get all zeros. Got them on the 0, 1, 2 index, got them on the 3 index, got them on the 4 index. Great. So now, once we have the diff sets, we're gonna need to do something like this. We're gonna need to loop, but the other way around. We're gonna start at diff sets dot length -1 until index is bigger than and equal to 0, and the index will go in the negative direction. So we're starting from the diff sets that only has 0, and then we need to do the algorithm specified, so to say. We need to add a 0, but there is a difference between the addition of this 0 and calculation of A and B, because A is actually this plus this, and B is actually this plus this. So we're gonna need to skip that. So we're gonna skip 1. But before that, we're gonna add an extra 0. So we're taking the last difference set, which the one that has all zeros, and we're gonna add an extra 0. We don't even have to do that since the one before that is 0 again. So we're gonna start from the one above that, and what we will do, we're gonna add an element, the one that's underneath it. The one below it will be the diff sets of index +1. The last element of the build will be the last element of the one below it. So in order to get this, the value for A, we're going to take this item and this item. So we have below, and we have current, which is this. And now we're going to say current dot push an item which will be the last from below plus the last of the current. And that should be it. And our result should be the last one of the difference. So let's console log that and let's return the result. So we should get 18 and 28. Let's see, 28 and 68. And then we need to sum them up, and the result is 114. Seems to be working. Once we defined it in a nice way, in a nice structure, the answer kind of popped out on its own. So let's see if something like that happens for the huge input, or we get all kinds of errors. Let's see. It says that the result part 1 is this biggish number. Let's try it. And that's the right answer. We have one more gold star. Let's take a look at the second part, what it is, the first time that I'm looking into it, and maybe we will solve it now, maybe there will be a part 2, but let's see. Even more history. We can extrapolate backwards. Sure we can. Beginning, fill in the first values. Yeah? Okay. The new leftmost history value 5. Previous value of -3 and 0 for the second, all these 3. The previous value? This sounds kinda identical. Let's see if we can maybe implement a method that's get previous value. So yeah, that's the diff set. So the last diff set, we're calculating the diff set, that's the same, and we're not gonna say push, we're gonna say unshift or shift. Yeah, unshift. And now we still need the one below us, we still need the current, and we might need to do some addition. So this is actually this minus this, and this is actually 0 minus 2 is minus 3. 3 minus minus 2 is minus 5. 10 minus 5 is 5. Yeah, so that makes sense. So we're taking this value and we subtract this value. So we need to get the current, which is not the last one, but it's the first one. Is there a first method? Maybe we want to... No. Basically, it's this. And the one below it. So what we want to do, let's go back to the small input. And we need to take the first one of the current and subtract the first one below that. And we're not gonna push, we're gonna unshift. So we don't need the first one, the last one of the first one, we need the first one of the first one. And let's see, so here the part 2 will be this. For the measurements, run through the measurement and get the previous value. Not the previous, but the previous. So using a direct plan of attack, let's see, we should have 14, 114, and the other is adding all three values together produces 2. Okay. Big input again. I'm kind of weary and I'm looking for loopholes because usually the tasks that are given on a weekend are the hardest one. But this kind of seems that it's not only easy, but maybe even trivial. So I do have a feeling that I'm not seeing something, and I will only lose that feeling when I see this, that we actually solved the second part as well. So, good news. This is a Saturday task. It's gonna be a one-parter video because the first one and the second parts are easy. And we actually made a nice method that we're gonna have in the array prototype that we can use over and over again, which is a great thing. So, don't forget to mash the buttons and keep developing.